test the hypothesis using the p-value approach. Be sure to verify the requirements of the test. So let's start out by verifying the requirements. So we want to check that n times p naught times 1 minus p naught is greater than or equal to 10. So n is 200, p naught is 0.7, so 1 minus 0.7. So let's do that on our calculator. So we have 200 times 0.7 times the quantity 1 minus 0.7. We get 42. So that condition's verified. And then we need to verify that we have a simple random sample. So we're going to assume that we have a simple random sample. Sometimes it'll state it, sometimes you're just going to assume there, or we can assume. And then lastly, we want to check that the sample values are independent of each other. So we have either the sample values are independent or our sample size is less than 5% of the population size. And here we're going to assume that this is true as well. So our conditions are met. So now what we're going to do is perform the test using the p-value approach. So I'm going to go into StatCrunch and type my information in. So let's do that. So we're going to go stat and proportion stats, one sample with summary. And then, let's see here. Our successes are 80. Our X value, our number of observations, our sample size, which is 200. And P is equal to 0.7. And the null hypothesis, null alternative, P is greater than 0.7. I'm going to check this p-value plot and hit compute. I'm going to hit this to expand it. So we have here that our p-value is 1. So your p-value should always be between 0 and 1 inclusive because it's a probability, right? So your p-value is the probability of obtaining a sample proportion as extreme or more extreme than the sample proportion obtained under the assumption that the proportion in the null hypothesis is true. So in other words, that's that the p-value is essentially true. Oh, sorry, not essentially true. The p-value is essentially the long-term proportion of times an outcome as extreme or more extreme than the outcome actually observed might occur if the statement in the null hypothesis is true. So here our p-value is 1. So it's pretty good probability, right? 100% there. So then remember that we compare our p-value to alpha. So I usually write it like this. And then I'm going to put our p-value underneath p-value and alpha under alpha. And then write my statement. So the p-value is greater than alpha here. Right? So when the p-value is greater than alpha, we do not reject the null hypothesis, right? So our conclusion here would be, do not reject the null hypothesis since the p-value is greater than alpha. Therefore, there is insufficient evidence, right? So anytime we do not reject, that means there's insufficient evidence to include the alternative. So always either concluding the alternative or not concluding the alternative. We're trying to find evidence for the alternative. So there's insufficient evidence to conclude that the proportion is greater than 0.7 at the alpha equals 0.1 level of significance. So we put that level of significance in there because it may change if we were to look at a different level of significance. So remember, when the p-value is low, the null must go. So that's the way I remember that when the p-value is less than alpha, we reject the null hypothesis.